Hi students, today we are going to see about ARM architecture. ARM architecture is something that advanced RISC machine processor. It is considerably a family of central processing units that has mainly used in music players, smartphones, wearable devices, and tablets, some electronic devices. So it is an advanced RISC machine create the ARM processor architecture. So it is said to be an ARM. Okay, this need very few instruction set and a transistor. It is very small in size and it is perfectly fit in every small devices, and it has a low power consumption and very reduced complexity. So many opt develop the application with the help of ARM processor, and it is basically applied to various designs such as 32-bit devices and embedded systems. And the main features of the ARM processor is a multiprocessing system, and it is tightly coupled memory and has a memory management, and it perform a thumb tool technology and one cycle execution time. And next one is your pipelining, and a large number of registers are there. The most common thing of ARM processor is not limited only to the mobile phones. It widely used in super fast supercomputers also. Let us see in detail. So this is the architecture of ARM. So here we see example of Cortex M3 and M4 processor. So it has a multiprocessing system, and multiprocessing is something that ARM processor are designed to be used in the case of multiprocessing systems, where more than one processor can be used to process the information. And tightly coupled memory is that the memory of the ARM processor is tightly coupled. This is very fast response time, and memory management is something that it has a separate memory management section, and this makes the system in managing the memory efficiently. And next, thumb 2 technologies was something that it extends 16-bit instruction initially and to 32-bit instruction in order to provide a better performance. And one cycle execution unit is something that ARM processor is optimized for each instruction on the CPU. Each instruction is of fixed length that allows time for fetching future instructions. Pipelining is something that processing of instructions is done in parallel using pipelines. Instructions are broken down and decoded in one pipeline stage. A large number of registers are used in ARM process to provide the large amount of memory interactions. Okay, so this is the main features of ARM architecture. So in your ARM architecture, it has the main components. ARM architecture is an advanced reduced instruction set. Is a 32-bit RISC processor, and it has an arithmetic logic unit and a booth multiplier and a barrel shifter and control unit and a register file. So in detail, the ARM processor has other components like a program status register, which contain processor flags Z0 flag, a status flag V and C, and the mode bits conjointly exist with the program standard register in addition to the interrupt and quick interrupt disable, and priority encoder. The encoder is used to multiple the load and store instruction to point which register within the register file to be loaded or kept. And here we have a mux. Several multipliers are accustomed to management operation of the processor bus. Then you have a arithmetic and logical unit. It has two 32-bit inputs. So the primary comes from a register file, whereas other comes from the shifter. And you have a status register flag modified by ALU outputs. Both multiplier factors three 32-bit inputs, and the inputs returned from a register file. And you have a barrel shifter. The barrel shifter features a 32-bit input to be shifted, and this input is coming back from the register file. Next you have a control unit, and the control unit is sometimes a pure combinational circuit design. It is implemented by easy state machines, and the process timing included within the control unit. And next is incremented for load and store operations instruction. The incremented updates the content of address register before the process core reads or write the next register. Next you have an address register. This holds the address generated by load and store instruction. Next you have an instruction decoder. It decodes the instruction opcode to read from the memory, and the instruction has to be executed. Next you have a register file, the bank of registers, which is 32-bit registers for storing the data. So the ARM has a load store architecture. The general purpose registers can hold data or address. So there are 16 registers located in the register bank, and 5 special registers are located outside the register bank. So this is the elaborated structure of register bank, and so all 13 general purpose registers can be used for load and store operation of instruction data and addresses. The registers are divided into two types, that is low register and high registers. That is from R0 to R7 is your low register, and from R8 to R12 is your high register. Most low registers are operated with 16-bit operation, whereas the high registers are operated with 32-bit operation, where R13 is a stack pointer register used to store the current stack addresses. So the Cortex M4 has two kinds of stack pointers, that is a main stack pointers and a process stack pointer, which is used for system organization and a user programming. Only one stack pointer is active at a time. And R4 is a link register, which provides some link functioning to set up a connection between a main program calling subroutines. So R15 is your program counter. This points the address of the next instruction which has to be executed. So next is your program status registers are divided into 3 different status registers, that is application program status register, execution program status register, and interrupt program status register. Next is your processor mode. ARM has 7 basic operating modes, and some operation can be carried out in a privileged mode. So next is your AMBA bus, that is an advanced microcontroller bus architecture. 3 distinct buses are being there in AMBA specification. One is your AHB, that is advanced high performance bus. Next one ASB is advanced system bus, and third one is your advanced peripheral bus. So this is a block diagram of AMBA bus. So it based on the 3 types, AHB provides high performance pipeline and bus transfers and multiple bus and bus masters. So ASB is high performance and pipelining operation. ABB is low power, latched address and control, simple interfaces, and suitable for many peripherals. Depends upon your application. You can select your AMBA bus. This is a block diagram of AMBA bus with various master and slave function. And here the input and output, if the input is 0 and if enable is 0, the output will be in high impedance. Where the enable is 0 and the input is high, the output will be in high impedance. Whereas the enable is 1 and the input is 0, the output will be is low impedance, that is 0. When enable and input is on, the output will be 1. So next is your pipelining operation. It has 3 stages. One is fetch, decode and execute. This is a basic block diagram of pipelining instruction, where you need to prefetch the instruction, and the instruction is decoded and registered read. Then the address where it has been returned back, and multiplied divide operations can be done, and finally it is return. Thank you. If you have any clarification related to this topic, please